All right, guys, so we're going to pick up where we left off yesterday. We finished this problem here. So we'll go on and look at this one here, and then one more with dealing with parentheses, and then one or two with factoring. Now, when we look at this problem here, this one would again be dealing with our square root method. And the reason that we do know that this is the square root method is because we have the x squared. It's the only variable that is being squared, and there's no other variables here. There's no variables x to the first. Now, we could have another variable in this equation that is x squared, because I could have 2/3 x squared on the one side and 20x squared on the other. And again, it's all just x squared. We can combine those terms and still use the square root method. The only way that we would know for sure that we wouldn't is if I had, say, 14x or 20x, x to the first power appeared in here, then it wouldn't work. So when we look at this here, we can do the square root method, and the first thing we need to do is get x squared by itself. So what can we do first? We can subtract 14 from both sides. And we subtract 14 from both sides, these will simplify to 0, leaving us with 2/3. X squared is equal to 6. We can divide both sides by 2/3 or multiply both sides by 3/2. It will give us the exact same answer. Now, if we had a calculator that would do it for us, we can go on and simplify. Yep, there should be right there on top. Now, if I have a calculator, we could do 6 divided by 3/2, and it would give us just fine. If I don't have a calculator handy, it's a little bit easier to multiply by the reciprocal. Because looking at this here, well, we can say 6 times 3 is 18 divided by 2 is 9. And these would cancel. So if we're having to do it by hand, it's a little bit easier to multiply by the reciprocal than it is to just to try to find or divide by 2/3. Because even if we did that, we would end up multiplying by 3/2 anyways. And last but not least, what do we need to do? Square root both sides. Now the square root of x squared is equals almost positive or negative 3, the plus or minus 3. Is negative 3 squared? Negative 3 times negative 3 is positive 9. 3 times 3 is still positive 9. We could have it both. Questions on this here? Now, our graphing method worked well if what? We had what kind of solutions? What did I say? Because when we did the graphing, we found the spots where the graph crossed the x-axis, yes? There were certain numbers that worked well, and what were they? They were what? Well, which ones didn't? If it's no real or prime, or if they have a what after them. Because they're either in one or two forms. Did y'all remember what the answer for this one was? Because x equals 3 plus or minus square root of 2 over 2, yes? Well, this gives me what? A non-repeating, non-terminating decimal, yes? Well, this one wouldn't be good for graphing because it gives me what kind of numbers? Decimals, yes? Because when we graphed, it worked well if the numbers were whole numbers, yes? They didn't have a decimal, it was 1, 2, 3. So this wouldn't work well. Could we have solved this one by graphing? Because what are the answers? Positive or negative 3. Those are whole numbers, yes? So we could have graphed this one, got it equal to 0 and graphed it, and it would have given us the answer. But we could have done it this way as well. As we saw in the last one, Is there a chance that we could get a decimal or a fractional answer here? Well, yes. Because if it works by the square root method, this will give us the answer every time. Graphing, it's hit and miss, because if it does work out to be a decimal, we've got to do a little more work to find it. And that's what we're going to find, especially once we delve deeper into this. Some of these methods work great in certain ways, others won't. We will eventually hit two methods that will work every time, no matter what the numbers are. They will give us an answer every time. And we will hit those last. Any other questions on this here? Let's look at this one here, because I want to look at one more with parentheses. And then we'll move on to factoring. So this one here, we do have a set of parentheses squared, and the variable is only contained inside those parentheses. We don't have it anywhere else. Because if we did, we would have to simplify those parentheses squared and get everything on the same side. But here, we can use the square root method. And what can we do first? Divide both sides by 2. And that will tell me here the 2 and 2 would simplify, leaving me with x minus 4 squared is equal to negative 5/2. Now what do we need to do next? Because the square root and square will cancel, telling me x minus 4 is equal to plus or minus. Just go on and give me the decimal version of that. Go on and type it in your calculator so we can get that, because we went over yesterday how we can go about using the yellow calculator to figure it out. We can break it up. And what do we get? You get an error, yes? So when we look at square roots, really what a square root is saying, we're trying to find a number that multiplied by itself gives us the number inside the square root, yes? So what we're saying is that a number times itself gives me negative 5/2, yes? Well, if the number is positive, well, positive times a positive is a positive, yes? Well, that's not what we want. So, okay, well, a negative times a negative is a positive. Is there any way that I can multiply a number by itself and it be negative? Well, no. This is our no real solutions. There are no real solutions. Because as we just said, there's no way I can multiply a number by itself and it turn out to be negative. It just doesn't work. But after tomorrow and Friday, we will be able to find them. We're just going to have to be a little bit creative and imagine a number that will work for this. Any questions on this here? We good with this here? Okay. The last type that we have here is solving by factoring. Now, correct me if I'm wrong, but I feel like we feel comfortable with doing this because we would get it equal to 0, 2 sets of parentheses and factor, yes? And that's all this is. It's not actually adding anything here. This here is not anything new. Finding the zeros. It's actually kind of self-explanatory because, again, when we're solving it by factoring or graphing, we're trying to find the values of x that make the function equal what? 0. So those x values are the zeros of the function. That's all it's saying. So here we could solve this by factoring or graphing or any of these methods that we have so far except for the square root method. Why can't we use the square root method? X squared is not the only one. We have 11x, yes? So square root method doesn't work. But we could solve it by factoring or graphing to get there, and we would find the zeros. The one that I do want to look at is this one here. Because I know I did skip a few, but I do want to look at 9, because 9's not something we've seen. It's not any more challenging than what we've covered already. It's just something a little bit different. We want to find the zeros. We want to find out what value of x will make this function equal 0. Now we could solve it by factoring or graphing. Let's do factoring. Is there a greatest common factor between x squared and 8x? Well, the number in front of x squared is 1, right? 1 and 8x really don't have any greatest common factors. Is there anything else that could be? Not 0, but there is something there. Do they both have x? This one here is one of the first ones we've had where we haven't had a constant term, right? Because it hasn't been just plus a number. Because a number without a variable is called a constant. But there is a greatest common factor of x, yes? So we can factor it out. So I can pull an x out of both of these terms. Because if I pull an x out of x squared, yeah, I have 2, I take 1 away, I'm left with x minus 8. Now, I mentioned this the other week where I talked about we can have a greatest common factor be a variable, and if it is, we can't just divide it out like we did with the numbers, because it would remove a 0, because it would take this x away. This solution to the function would be removed if we'd have just divided it out, but we do need to factor it out. Now, do we have two things multiplied together to equal 0? Oh yeah, x times x minus 8. So that means either x is equal to 0 or x minus 8 is equal to 0, yes? Oh, wait a minute. What does this say? X equals? X already by itself, it equals 0. We're done with that one. Here we have to that's it. So again, like I said, this wasn't anything more challenging than what we did. It's just recognizing the greatest common factor of x. Wait a minute. If I do have a polynomial where I have no constant term, what do we think one of the solutions is going to be? 0, because if every spot in the polynomial function has a variable, an easy way to cancel them all out is just plug in 0. So if there is no constant term is just a number, then most likely 0 is going to be a solution. And really, because that's about what we'll do today, but I just want to look at constant term just for a second. Because when we talk about something being constant, it is the same, it doesn't change, right? Because with any of these functions, the value is changing by what value I plug in for x, yes? Also in the other one, 49, no matter what I plug in for x, anything in for x, will that number change? No, it's 49, right? It's not affected by x. So it is a constant term. It is considered to be constant. Really, the x itself is considered to be the linear term because it's to the first. X squared is the quadratic because it's to the second. But that's a constant term. And you'll hear that especially if you take college algebra going up, they'll talk about the constant term, the linear term, the quadratic, and it's really referring to the variable. what number's in front of the variable.
But that is?
Yeah. I did plan on this being finished a little bit early, because again, part of this is dealing with using the graphing calculator and graphing these. So go on and work on this here, especially try to get the ones that involve graphing done first. That way, because you have the graphing calculator here, you can go on and get those done. And that finishes 3.2.